We want to talk to you about options on managing non-wetting sands. Non-wetting sands are quite a big issue to WA community, or to the WA state. And if you look at this map here, you'll see that there are over 3.3 million hectares of the soil of the state which are at risk of non-wetting. 6.9 million have moderate risks of non-wetting soils. So you're looking at the orange, pink and purple areas across the state. Look, Steve's shown that moldboarding is a really good tool to manage non-wetting soils, with results that have shown good production over an 8-year period. But let's be realistic, we cannot moldboard 3.3 million hectares of the state. It was around the early 1990s that Paul Blackwell showed the value of furrow sowing, and that was for a water harvesting, from a water harvesting perspective. But the reality is that furrow sowing on non-wetting soils isn't often effective. And so in the words of Professor Sumner Miller, why is this so? Steve, can you give us a bit of a rundown on that?
Yeah. So look, there's a number of issues that can occur with furrow sowing. Certainly, you know, the actual idea behind harvesting water into the furrow and getting that wetting up of the furrows is is a perfectly good one. But what we tend to see, I guess, in these repellent soils is that furrow is very inconsistent in its wetting. Now, part of that's driven by a number of factors, but certainly one of the drivers is the fact that with these non-wetting soils, obviously we end up, even at seeding, with quite a significant amount of dry patch. And you can sort of see that in the image there with the blue dye. And you can see that on these soils, the water tends to enter the soil through preferred pathways. So there's certain pathways, whether it be along old root systems or even small changes in the mineralogy, or in a sense small dips in the soil where the water can pool for long enough that this is where the water will enter, and much of the soil will remain dry. So when we're furrow sowing with knife points are actually designed to sort of break out some soil for that soil to flow around the point and be left on top of in the base of the furrow on top of the seed as tilth that then gets pressed down by the press wheels. But on these soils we end up with quite a lot of this repellent soil actually being the dry stuff that flows around, ends up basically surrounding the seed and the fertiliser, and the water as it infiltrates that soil diverts around that. And again, there's some of those images there show sort of how that happens. So that's kind of the problem that we have with furrow sowing, really. You can see in this image that, you know, here's a case of where the furrows, again, just using blue dye to look at infiltration. This is a case of where the furrows are working a bit, but you can see it is still quite variable between different furrows. So for some, the water's infiltrating quite well in some areas. In other areas, there's still dry patches, and so your seed placement within that becomes quite critical.
Thanks very much. Steve, I wanted just to touch base to give you an outline of what the key messages for today are, and to outline the research that we're doing. But what we're wanting to look at other agronomic options to manage non-wetting sands that doesn't include moldboarding. And so the three key messages that you'll come away from today is that seeding rates can have a bigger impact on weed establishment than wetting agents. Higher seeding rates on the soils with low yield potential can actually be a disadvantage, and that delayed seeding opportunities do provide opportunity for weed knockdown, particularly on those non-wetting sands. So, as I mentioned, what are the options that we have that are not going to include moldboarding? And delayed sowing is one option, increasing seeding rates is another, and wetters are the third. So Steve, can you give us a little bit of a rundown on how the wetters can potentially have value in the system?
Yeah, thanks, Chris. Look, the soil wetting agents, if you think of, like we think with herbicides, we think about modes of action. Well, if you think of soil wetters in the same way, there's basically two main modes of action. Now, all soil wetters basically have the first mode of action, and that is basically just to act as a penetrant for water into those soils. So it basically enhances the infiltration, and in general terms, there is some mucking around with different chemistries, but in general terms, it's mainly a surfactant effect. So it basically helps that, in a sense, almost makes that water thinner, and that helps it actually penetrate and infiltrate into those repellent soils. One of the issues with that is the same process that helps it enter and initially infiltrate into those soils can actually mean that the soil water retention is reduced, so that water actually drains further through soils which are already, highly leaching anyway. So one of the issues with that is obviously they can carry nutrients, and there were some results in the early days showing a positive impact of soil wetters on establishment, but a negative impact on yield, and that was largely down to problems with enhanced leaching. So one of the other second mode of action that has been introduced to some of the options, the soil wetting agents out there, is a water retention, so a hydroscopic water retention capacity. So these products can absorb moisture and hold greater than their own weight in soil moisture. Now that sort of sounds exciting, that, oh wow, we can improve the watering and holding of our soils, but you've got to realise these things are going on at a rate, they're sort of banded into the furrow, and they're going on at a rate of 2 litres per hectare. So, the very small volumes means that the actual water holding, in a sense, is basically insignificant, but it's more the fact that it's reducing this leaching problem.
Thanks, Steve. So, how did we? So our aim was to use a systematic approach and to assess how delayed sowing, increasing seeding rates, and wetters can add value to increasing establishment and the yield of wheat on non-wetting soils. So how did we do that? In 2014, we had 4 locations, 4 trials, I should say, across the state. They were located at Benue in the north, Eneabba, which is about 200 k's north of Perth, Benue about 400 kilometres north of Perth. Then we went down to 2 locations in the south, and they were Yularing and Cranbrook. We had 2 sowing times, 2 seeding rates, and we had 6 wetter options that we also incorporated into the trial program with a control as well. Our aim was to get the sowing done dry, so we aimed to have dry sowing at the end of April, and then to have dry sowing in April, and then 2 to 3 weeks later we then went in with a second sowing time that was into like a moist soil profile. So I'll explain a little bit more about the locations shortly, but Steve, can you give us a bit of a rundown on how the wetters impacted on establishment?
Oh, okay, yeah, look, in terms of the soil wetters in this particular season, I mean, Chris will probably touch on it a bit more, but we had very good opening rains at a lot of these sites, and so really we only got dry seeding, ended up getting dry seeding at a couple of the sites, and at one of the sites the dry seeding kind of happened, and then we got a lot of rainfall. But we did see, actually really only at one of the sites did we see sort of a significant increase in crop establishment, and that was at Yularing. And basically for most of the products we tested, so we tested 6 available products and 1 development product, they gave basically pretty much a 20% increase in crop establishment. The thing was, that was on top of actually what was already a reasonable establishment, even without those wetter products. So the reality was that we basically had enough plants for yield potential even without that additional increase in plant establishment.
Thanks, Steve. So we're just going to now just run through the 4 sites and look at how, just really focusing on the seeding rates and delayed sowing on establishment and yield. So this is our Benue site. It was sown on the 26th of April, and no kidding, we'd just finished the last run, and like 2 minutes later, as Steve said, it just poured down, and we had those really, really good opening rains in April. So we sowed with mace wheat across all the trial sites, and what you can see here is that increasing seeding rates were able to increase plant establishment, so at each of the sowing times. But this was a really harsh environment. The site and the season was very, very difficult up there. Sowing mace at the end of April is most probably not a really good opportunity or good option, and when you have such a harsh winter, because we had it flowering towards the end of June, head emergence and starting to flower at the end of June. So it was, like I said, it was a very harsh environment. And as you can see here, we didn't get good yield potentials at those sites, or yield production. So in the first sowing time, half a tonne, one head came up, it just didn't get that chance to really get a lot of biomass early on. With the delayed sowing, which was those 2 weeks later into the mid-May, yields did increase a couple of 100 kilos. There was the lower seeding rate of 60 kilos a hectare increased significantly yield to about 0.7 of a tonne. But as I said, this was a very harsh environment, and we were, it just struggled the whole year through. This is the Eneabba site. So both Eneabba and Benue had severe water repellents. What we noticed at this site was potassium deficiency, and you can see what I'm just trying to illustrate here is the windrow effect. When we went out there to do the plant counts, and we looked and we saw this windrow effect, and we used the microp tool to help diagnose it. And Travis came out and showed us as well, talked to us about it. There's a real potassium deficiency that was observed at that site in the canola windrow. So what were the yields and the establishments that we experienced or we observed at Eneabba? So that site, in actual fact, establishment did increase once again with increased sowing time. We did have a reduction in establishment with that second establishment, so with that second sowing time. So, but at Eneabba we didn't sow dry. So Benue we did get that dry sowing. At Eneabba we sowed into moisture after those opening rains in April, and then we had a second sowing time 2 weeks later. In terms of yield potential, it was the first sowing time where we had the higher yield in actual fact, which is what you would expect in terms of earlier sowing. But once again, this site was, for the amount of rain that site got. Steve, do you recall how much rain it was?
A little bit over 400 mil growing season rainfall.
Yeah, so when you look at the amount of rain...
disappointing yields.
Yeah, and the grower himself was very disappointed as well at that site. But, the yield potential, or the yields that we observed there once again, it was a very harsh environment on those soils which have got very poor soil water holding capacity and nutrient as well. This is the Cranbrook site. What I wanted to show here is weeds. So what you're looking at here at the back is, this is the first sowing time that was sown dry, and then with those opening rains, what you're seeing here is the amount of weeds that were coming up prior, following those opening rains.
Or good clover if you like sheep.
Sorry,
perspective.
Weeds, aca clover. And so what we found there was that it was the site was really struggling to weeds were a real problem, and getting on top of the weeds was a real issue at that Cranbrook site. We didn't actually get plant establishment measurements at that site, but what this yield data is illustrating is the impact of the weeds on yield potential. So what you're seeing is that with that first sowing time, and by delaying sowing time by those couple of weeks, you increase production on by about a tonne at this site. Now this is in the south coast, and this longer growing season environment, higher rainfall, and a softer season than what was experienced up in the northern ag zones. And this is finally the Yularing site, once again illustrating that weeds were a real problem at this site. With 5 minutes, thank you. And these are our the yields. So we had a problem with sheep. They ate the first sowing time, so we don't have some yield data there, so it wasn't available. But we still got, we would expect at this site that we would have a similar response as what we would have got at Cranbrook, that we would have had, the weeds would have had a big impact on production on that early sowing time. And unfortunately we only had plant measurements in that at the first sowing time. It's a little bit difficult when you're managing trials from one end of the state to the other. Steve, what happened with the wetters in terms of yield?
Yeah, so look, in short, not much, but yeah, we actually did see a yield response to only certain products at one site, and it was interesting the site that turned out to be, because if I sort of took a poll, probably not the site that you would guess, but it was actually at Benue that we saw a response to soil wetters, despite the fact that we had a really dry June, July and August up there, and it got hot. And what we sort of observed, I guess what sort of put us onto it initially was I went out at one stage and there were certain treatments where you could visually see that the plots were darker green and looking a bit better, and it was the same treatment and it was in every rep. For both sowing times, it had actually come out, that particular, or a couple of the particular products. So what ended up happening there was we basically got around 100 to 120 kilo yield response to certain products at that site. Now doesn't sound like much, but when you're talking about your control yield being around 400 kilos, it's obviously, if I express that in a percentage, we'd all be going, oh wow. What we believe basically happened was the rainfall events that did come through June, July and August were generally quite small. So you're tending to talk about just a few mils, say 3 to 5 mil rainfall events. And if you can imagine, quite a strongly water repellent soil, there is very little chance of a 3 to 5 mil rainfall event ever actually getting anywhere useful in terms of getting into the crop's root zone. Most of it will just sit there and evaporate off. Those yields obviously reveal that did happen quite a lot. But it did appear that with this particular wetter, which was one of the stronger penetrant types, I suppose, that it probably actually allowed that rain that did collect in the furrow to actually penetrate deep enough for the crop to get that little bit of extra value from those small rainfall events. So, we don't necessarily have the detail to back that up, but that would be sort of what I would put it down as the most logical hypothesis as to why that happened, and why the particular products that work quite well were the ones that have tended to perform reasonably well in our trials over the years on the sands, and they tended to be fairly strong penetrants. Yeah.
Thanks, Steve. So what we've tried to illustrate is that on those non-wetting sands where we're trying to get good establishment, increasing setting rates is obviously a tool to maintain good establishment on the sites. Delayed sowing is going to have a value in terms of enabling the soil to get more moisture, but there are other potential opportunities out there, Steve, that we could potentially look into the future, like variable rates and on-row seeding.
Yeah, I guess we're just wanting to make the point that, okay, we've looked at some of the agronomic factors, and a few things conspired against us, like, sheep really wanting to get at that clover that we couldn't kill, and knocking down the wheat crop in the process. But yeah, look, I think one of the things that is showing certainly a reasonable amount of promise is the on-row seeding, where you basically do seed right up next to the previous year's crop row, and there's no doubt that those stubbles and those root systems and those crowns act as a preferred pathway. And you only have to go out into a repellent site after the first rains of the season and dig across your previous rows, and you will see, I can almost guarantee it, you will see that where those old crop rows are preferential pathways for moisture. And you can see an example of that down there, which was down south last year. I think just in terms of mentioning variable rate, it's not so much that variable rate's going to overcome your repellents or your establishment, but on these repellent soils, I think of the site at Eneabba there, and the reality is, okay, we could do something about improving establishment, but we were still battling with poor fertility, and we were really battling with the fact that on those soils, you don't actually need many dry days on this real pale, deep white sand, silver loams or whatever they call them, cutlass sand. You don't need many days before crops become stressed. You don't need many hot days before crops really just cannot pump enough water out to stay cool and to protect their yield. And so the reality is, on some of these areas, it is a case of trying to farm them to potential, and I guess that's where the whole variable rate thing comes in that we need to think about, well, is it a case of getting the fertility up? But even then, you're still going to need to sort of manage that for its yield potential, because the poor guys, they're lovely people down there, nice, lovely part of the world, really quite good rainfall, but these soils just really hold things back, and they do, go from cliff, they really do drop off a cliff from going from their good soils to their bad soils.
Thanks, Steve. So I just want to finish off there, and really, what our findings have confirmed is that managing these non-wetting soils is a challenge. We know that growers we know that the higher rainfall, longer season environments, that delaying sowing is going to be an option for those areas, because they still have the opportunity to get potential yields with those later sowings. But it's for those farmers in the where they have a shorter growing season, like Steve was mentioning, where the challenge will be to be able to get early enough establishment and crop establishment, and to be able to make the most of the soils that are there. So the call to actions really are that seeding rates have provided more benefit to establishment than non-wetting sands, that higher seeding rates on soils with a lower yield potential could be more problematic, could be a disadvantage on those lower productive soils, and delayed seeding opportunities will still be an important part of managing weeds for those growers where we have that problem. So thanks very much for your time.